Okay, for these examples, we're going to be simplifying these equations using Boolean algebra. So the first example is a consensus pattern, or a consensus rule or theorem, or however you say it. The way I like to look at this is I like to look at what exactly these are made out of. So we see A in all of these. We see B prime in all of these. And the only difference is this C prime and C. So because C prime and C are in the other two, we look at which one is missing C prime and C. And that is the first one here. So we multiply the first one, AB prime, times C plus C prime, because this is just equal to 1, plus AC prime plus B prime C. So we distribute this in. So this will be AB prime C plus AB prime C prime plus AC prime plus B prime C. Now I like to look at what are they made of and what do they share in common. And I'm going to mark these different colors. So the first one, we have B prime C, which is also here, B prime C. The next one is AC prime. I'm going to see that here, AC prime. So we're going to pull that out of each of these. So I'm going to have B prime C times A plus 1, because when I pull this out, it just equals 1. Then I'm going to have AC prime times B prime plus 1. And it's the same thing where this one here turns into 1. So because of that, I can cancel these out. Cancel out, cancel out. Because they're just equal to 1. So my final answer is B prime C plus AC prime. The next equation is x prime z plus w prime x y prime plus w, and then distribute into these. The first thing that I want to do is I want to distribute this w into these. So I'll write x prime and z, or w prime x and y prime, or w and x prime and y, or w and x and y prime. Now I'm gonna look at, do they share anything in common? And if they do share it in common, I want it to be in common across multiple of them. So I can see across these two, I share a xy prime here and xy prime there. So I'm gonna start with that, and we're just gonna pull that out and see what happens. So we have x prime and z, or x and y prime, and then w prime, or w, or x prime w y. So this here is just equal to 1. So this actually cancels out. And we get our answer of x prime and z, or x and y prime, or w, or x prime, or y. And then we look, do anything share anything in common that would really do anything? So we do see here that these two do share an x prime, but if we were to pull that out, we wouldn't get anything out of it because they don't share. This z isn't included in this one at all. So our final answer is just x prime and z, or x and y prime, or w x prime y. And that is our final answer. Next question is xy, or xz, or y and z prime. Now this is another consensus rule. I can see it right away, as we talked about. These share an x, these share a y, and these are different, the z and z prime. So I see this and I say, okay, which one is missing the z and z prime? And the answer is this one right here. So I'm going to multiply in a 1, which is my z or z prime. So to do that, I'm going to make this black. I get x and y. I'm going to bracket this off. And z or z prime. I'll bracket this off because I want to express these first. Then or x and z, or y and z prime. Now I'm going to distribute this, so I get x and y and z, or x and y and z prime, or x and z and y and z prime. Now I'm going to look at, do any of them share this, the x and z? And you see currently right here, and right here, we have the x and z. The next one is going to be the y and z prime. And we see that right here, we could pull that out. So the first thing I'm going to do is pull out that x and z. So I'm going to do x and z, get this in brackets, so we really see what's going on here. Then we're going to drop down this y. And this one here is just a 1, as we stated before. It's just a 1. So I multiply this in, I get x and z and y, or x and z. So close up my brackets, or create new brackets. This one is the y and z prime that I'm multiplying by. So I have x or 1. So, as I said before, this is just 1. So boom, boom. We can cancel these out. These will always be 1. Regardless of whatever y is here, it'll always be 1. If it's 0 or 1, is 1. 1 or 1 is just 1. Same here. Doesn't matter what x is. It is always 1. So we can cancel that out. So our final answer is x and z, or y and z prime. And I'm going to box this. Does anything here have anything in common? Because multiple ways to go about this, but I'm just going to go about the way I found the easiest. Does anything have something in common across all of these? And we do see that. We see all of these share a c prime. I make that a little clearer for you. So I'm going to pull a c prime out. So now I have a prime, or d prime. Then I have an a prime, or d prime. Now, much easier way of writing this, I can also just write this as just these two together, because they are multiplied, and it doesn't matter which way they go. So next, I want to distribute all of these into here. So I get c prime, or a prime, d prime, or a prime, d prime, d prime. Now, when we see this, a prime, it's just a prime. Same thing for this one. D prime, it's just d prime. Because if d prime is 1, 1 times 1 is always 1. 0 times 0 is 0. So I can write this as c prime, or A prime, D prime, or A prime, D prime. Now when I see this, these two are exactly the same, so I don't need both. I just need one of them. So I say C prime, or A prime, or D prime. And that is our final answer.